Assalamualaikum warahmatullahi wabarakatuh, and a very good day to everyone. Today this video is going to be talking about sound-based lighting. So, in modern homes and workplaces, convenience and efficiency have become major priorities in the design of everyday system. The sound-based lighting system is a project developed with these goals in mind: to create a lighting setup that can be controlled by sound signals such as clap, a manual switch, or an oral command. The idea is to minimize physical effort and make lighting control more accessible, especially in situations where reaching for a switch is inconvenient or impossible. Traditional lighting relies solely on physical switches, which may not always be within easy reach or practical to operate. For example, when entering a dark room, carrying objects, or assisting people with mobility challenges, this can reduce comfort, convenience, and accessibility in everyday life. To solve this, the proposed sound-based lighting system detects specific audio cues, such as distinct sound for clap or a spoken command, using a microphone and signal processing circuitry. The detected sound is interpreted by a microcontroller or logic circuit, which then activates or deactivates the light accordingly. By integrating both manual and automatic sound activated modes, the system ensures flexibility, energy efficiency, and user convenience. The primary objective of this project is to enhance user convenience and automation by enabling light to operate through sound-based input. In addition, it aims to provide an accessible lighting solution for all users, including the elderly and differently able. It also promotes hands-free control to improve safety and comfort. It also combines simplicity, affordability, and reliability in an easy-to-build system. Ultimately, the project demonstrates how simple electronics and sound detection can be combined to create an intelligent, user-friendly home automation feature.
Before we dive into the building process, let's clearly state the purpose of this project. We have four main objectives. Our first and most fundamental objective is a demonstration of the core principle, transduction. We aim to show you exactly how sound, which is a mechanical wave, can be captured by a sensor, convert into a measurable electrical signal, and then used as an input to control an output device, specifically a light source. Secondly, we want to move beyond the theory and explore the practical applications of sound-based lighting. This is not just a lab experiment, it's a technology with real-world users. Think like automated hallway lights that activate when they hear a person approaching, or even advanced stage lighting that syncs automatically with a music performance. Understanding this application gives the object context and value. Our third objective is the hand-on implementation. We will walk you through the process of designing, selecting, and necessary components, such as the microphone, amplifier, and controller, and ultimately building a simple functional sound activate light system ourselves. Finally, we will investigate the system's sensitivity and response. We won't just confirm it works. We will religiously test how the light reacts to different types of sounds, a clap versus a continuous tone, varying intensities, and whisper versus a loud shout. These help us characterize the performance of our sound activate light.
Now, I will present about the materials and methodology for this project. First, the materials. We need several materials for this project. We need microphone, LED, relay module, Arduino, connecting wires, battery, breadboard, and resistor. First, the microphone. Microphone will receive a sound and send a signal to the Arduino. Then, the Arduino will receive a signal and control the relay module. The relay module will act like a switch to turn the light on or off. Then the LED. LED will lights up when receive a power from the relay module. Then the battery. Battery will provide the power to the circuit. Then the connecting wires. Connecting wires will connect all parts together. Next, the breadboard. The breadboard will holds all components and makes connection easier. Lastly, the resistor. Resistor will protect the components by limiting the current. Next, we move to the methodology. The first step for this project is prepare all the material such as sound sensor, Arduino, relay module, LED, breadboard, and wires. The second step is connect sound sensor and relay module to the Arduino. The third step is connect LED to relay output terminals. The fourth step is upload the Arduino program that controls the relay using sound input. Next, connects the Arduino to the power supply. Then, test the system by clapping or making a sound to turn the light on or off. Then, adjust the sound sensor to make it more or less sensitive. Lastly, arrange all the components neatly inside the box for safety. That's all for the materials and methodology.
Lighting. Let's explore where this technology is already making an impact in the real world. We can categorize the major application into three distinct areas: safety, daily life, and emergency situations. First, the use of sound activates light significantly enhance safety. The core principle here is deterrence. If a light suddenly illuminates when a suspicious noise is detected in a dark area, it can often scare away a potential intruder or alert neighbor to a problem. Example, imagine a dark backyard or a storage area. If a sound activate flood light suddenly turns on because it detects the sound of footsteps or a door being pried open, it acts as a very effective deterrent. In public spaces like parking lots or a light, they help increase visibility exactly when and where is needed. Secondly, category is the integration into daily life, focusing on convenience and accessibility. The description on the slide mentions that the light responds to sound like a clap or voice command. This is about making interaction with our environment simpler. It's often used where reaching a switch is difficult or inconvenient. For example, consider a person walking into a room with their hand full of groceries. Instead of fumbling for a switch, a simple clap or a predefined voice command can turn the light on. This technology is incredibly useful for improving accessibility, particularly for the elderly or those with mobility impairment, allowing them to control their lighting with minimal physical effort. Finally, and perhaps most critically, we see application in emergency scenarios. The slide points out a very specific and high impact application: traffic control. When every second counts, this technology can save lives. For example, picture an ambulance or a fire truck racing through the traffic light using acoustic sensors. The traffic system can be configured to detect the unique siren pattern of an emergency vehicle. Upon recognition, the system automatically cycles the traffic light ahead of the vehicle to green, immediately clearing the path. This allows first responders to reach their destination faster, minimizing response times and improving overall public safety.
This product has four different outcomes. First, it's simple. The system successfully detects claps or voice command to control lighting, providing inconvenient and hands-free alternative menu switch. It also benefit focus. The project delivers a hands-free lighting solution that improves accessibility, convenience, and ease of use in everyday environment. Moreover, new industrial marketing can prove that sound activated lighting is particularly effective and suitable for modern smart home applications
make many investors to invest in making the new lighting project. And lastly, for technical, the prototype equipment responds to sound input using a microphone and signal processing circuit, demonstrating reliable sound activated lighting control. And that's all from me. Let's hear from our next presenter.
Next we will move on to the challenges. So there are three challenges that So next we will move on to the challenges. So there are three challenges that we found during our research. The first challenge is that the sound sensor has a limited range of detection. So if a sound is too far away or if it's too quiet, the sensor just won't pick it up. It has a limited distance at which it can detect the sounds. This means that if you just clap outside the sound sensor, the sensor's zone, if you make a sound that's too soft or it's too quiet, the sensor will not detect it, and the purpose is not fulfilled. Next, the second challenge is that it has a high sensitivity to background noise. So basically the sensor would be confused as to whether what sounds it has to react so that it could function. So basically the sensor is trying to hear specific sounds like a hand clap or a door opening, but it also hears everything else happening around it. Things like, for example, car driving by, air conditioner, or even someone talking. So these mistakes can lead to a bigger problem that is faulty in the light switch. And the third challenge is the delay in response. So like this, picture this. Uh, Imagine that you clap your hands, and you would think that the light would turn on at the same time that you clap your hand, but no, it will have a delay because some transmission is not really that efficient. So first it has to decide if your sound is real and not just background noise. And then it has to send the signal to the light switch. If this whole process takes too long, the system will feel slow, or basically it will has a delay. A fast response, because when we use this acoustic sensor as a light switch, we would expect to hear a fast response. Like when you clap your hands, you would expect that the light would turn on immediately rather than waiting a few seconds for it to turn on. And that is all for the challenges. So, in conclusion, we successfully demonstrated the sound-based lighting system. Our acoustic sensors reliability on detecting noise, it activated the circuit relay and automatically controlled the light source. So this project validates that this is a truly efficient and hands-free lighting method. The resulting system is defined by its simplicity and its low-cost maintenance, making it highly accessible to people. And this system is also especially useful in environments where hands-free operation is critical. For example, when you are too busy to do something that you cannot afford to go to somewhere to switch on the light. Like, think of when you are in a dark room and you are unable to see where the switch is. You can just clap your hand and the light will turn on. And the core takeaway for this is that we have proven the sound can be used effectively and reliable as a trigger to control not only lighting but a wider range of electrical appliances. So that's all from us. Thank you.